Hello, everyone. Good morning, good evening, and good afternoon, wherever you're joining from. My name is Naresh, and I welcome you all to our AWS User Group Nagpur April meet. I'm very excited about this meet because this is our first online meet. We have done multiple offline, but this is our first. I'm very excited about it. My co-lead Jyoti, are you excited?
Yes, of course. I'm also very excited because this is our first ever, virtual meetup.
Right, absolutely. I'm very excited about this. And meet our wonderful team who is going to put this show behind like everything, all the effort which has gone. So these are our core team and all our volunteers. And a quick 1 minute, like why this community. So we started this community so that we can share knowledge, we can give platform to others who want to share knowledge, the issues they have faced in production, any hands-on they want to take, workshops. And of course we will be doing this monthly meetups, and that is what is our intent. Last month, I would say last couple of months, we did 4 sessions in college as a boot camp, where we presented on AWS services. And the next logical question is how can you help, right? We have heard this question that how can I help being part of this community? I also want to contribute. So there are ways, for sure. If you want to speak as a speaker in one of the sessions, you're most welcome. Even if you do not have content, let's say for 30 minutes, you can still give a lightning talk. So we have all those options. This is a platform for you to present whatever you have learned in real production situations. If you want to arrange any sessions in your college, do reach out to us. We are there to help you. If you want to publish, write about us, help us in promotion, and of course, very important is sponsorship, right? If you want to sponsor us, do reach out to us. And for today, we have got two great speakers who will be sharing their knowledge. Everyone is under the pressure of delivering high performance, low latency applications, right? But then how do you do it? AWS has got those services, and that is what Abhishek is going to talk about. And we have another great speaker, Sankalp. He is going to talk about a buzzword, MCP, right? And EKS, the Kubernetes managed service of AWS. He is going to share his experience on how can you manage EKS with MCP. And I'm sure after this session, MCP will not be a buzzword for you, but that this is something that you would really want to practice. Um, for those who are not yet part of the community of AWS User Group Nagpur, please do join us on LinkedIn. And we have our website as well, where you can find details of all the sessions we have had done so far. And please do take a look at that as well. So with that, I would request Abhishek, uh, if he can take over the session, and yeah, let us through the journey of AWS CloudFront, security, WAF, everything. Abhishek, over to you.
Hey, thank you, Naresh. Thank you, everyone. Thanks for joining this today's session. Really excited to be a part of AWS User Group Nagpur community and being the first speaker for this online meetup seems really exciting. Before we begin, a quick introduction. So I'm Abhishek, co-founder of and CTO at Whistlemine Technologies. Over the years, I've worked closely with OTT platforms, e-commerce businesses, and fintech companies to design, scale their internet-facing applications. A large part of that journey has involved optimizing content delivery using CDNs, CloudFront, securing applications at the edge, leveraging WAF, and protecting critical workloads from real-world threats like DDoS attacks and bot traffic. In my role today, I focus on helping teams move from basic setups to production grade architectures where performance, availability, scalability, security, everything are built in from day one and not added later. So, in this session, we'll be exploring how to design modern age architectures on AWS. Specifically, we'll look at how services like CloudFront, WAF, and Shield can help improve both performance and security for the internet facing applications. I'll keep this session a little practical So, and we'll also walk you through a quick demo to make things more concrete. So, let me quickly walk you through the agenda today. We'll start with some fundamentals to understand what edge architecture actually means and why it matters. Then we'll dive deep into AWS CloudFront, WAF, and followed by a conceptual overview of what Shield and Shield Advance is. After that, we'll move into a short live demo where we'll configure some of these services, and we'll finally wrap up with some use cases and take up your questions. So, what is edge architecture? So, imagine that you're ordering a food from of your favorite restaurant, and if that restaurant operates just from one central kitchen located very far away from you, what would happen is it would take time for that food order to reach to you. So, basically, in that scenario, the food would be cold. It won't be maybe it would be not very good when it reaches to you. So similarly, picture this into a different model. Instead of one central kitchen, let's say the restaurant has multiple kitchens spread across the different localities in the same city. So whenever you place an order of that food, maybe it gets prepared in the kitchen which is very closest to you. What is the result? It has a faster delivery. You get a fresher food, and you have a much better experience. That's exactly what edge architecture is doing for applications, or I would say an internet facing applications, your websites, your web apps, everything. So traditionally, applications were like that single central kitchen. Everything was served from one region or one data center. So every user request had to travel all the way to the data center, which is far away from the user location, so which added latency there. With edge architecture, we move that key parts of that experience, like content delivery and even some computation, closer to the user using geographically distributed edge locations. So whenever a user is making a request, instead of going all the way back to the data center or to your actual content where it's stored in the data center, it can be handled much closer to them. This is drastically reducing down the latency and is improving the performance for the user. So, but there's another powerful advantage here. Since requests are now hitting these edge locations first, we also have the opportunity to inspect and filter each of this request at the right of the entry point itself. That means if this request is malicious or is coming from a bot trying to attack the web application, we can enforce some security controls which can help protect our backend systems before even it reaches to them. So, in simple terms, edge architecture is about two big shifts: bringing speed closer to the user and pushing security earlier in the request lifecycle. So, why edge matters? Edge architecture plays a very critical role in modern applications because performance can directly impact user experiences and business outcomes. Faster load times can help improve engagement and conversion rates, mostly into an e-commerce applications. And at the same time, by serving content from the edge, we reduce the load on the origin servers. So this is kind of helping your origins not overflood by serving the requests on a very high on a high scale. So another important benefit that it introduces is a security layer that filters all the requests that land onto your edge, and it is being filtered even if it is reaching to your backend infrastructure. So let me quickly walk you through what CDN fundamentals are. So a content delivery network. CDN is called as content delivery network. It works by caching the content at this distributed edge locations. So when I say edge locations, these are actual servers which are located closer to the user location from where he's making the request. So whenever a user makes a request, a CDN serves the content from its nearest location. And if this content is already cached, it's called the cache hit, and the response is really very fast. If it's not cached in that particular edge location, we say it's called as cache miss. And this particular request goes back to the origin, gets the content, and stores it, a copy of that content onto the edge location, and then serves it back to the user. So, and the duration for which this content is cached is called as TTL, or time to live. So these are the basic fundamentals in CDN, or content delivery network, or in CloudFront, which is like cache it, what is cache miss. We have TTL, that is time to live of this content into the cache servers. And then we have the origin server fetch, which is a cache miss, and you get this request served from the origin itself. So coming to AWS Edge Stack. So AWS provides a comprehensive edge services, which combines of performance and security. So AWS CloudFront is used for content delivery, and WAF is used for application level protection, and Shield is helping to protect against the distributed DDoS attacks, or I would say the denial of service attacks. And whereas if we have to do any computation, uh, we have Lambda at edge or CloudFront functions. So computations like redirecting requests, trying to see the IP addresses, or doing a redirections, we can use this CloudFront functions or Lambda at edge functions. So together, these services create a architecture that ensures both speed and security for your web applications. Let's walk you through what is CloudFront. So CloudFront is AWS global CDN with hundreds of edge locations worldwide. It supports both static and dynamic content, and integrates seamlessly with services like S3, application load balancers, or even your custom origins. It now also supports modern web protocols like HTTP2 or HTTP3, and which further improves performance and efficiency. So to understand CloudFront better, let's take a look at the request flow. So whenever a user is making a request, it first reaches to the nearest edge location. CloudFront is now checking in its cache behavior rules, basically, which are being defined in the configuration to determine how to handle the request. If the requested content is cached, it is served immediately to the end user, not being forwarded to the origin. But let's say the content is not cached, it the request CloudFront now forwards this request to the origin, and the origin sends the response to edge location. Edge location stores it, and it then sends to the end user. So in this, we can also have the origin failover, configured to improve the availability of your uh, content here. So whenever, let's say, you don't have an object in your one S3 bucket, you can have an origin failover, configure that, okay, you don't find an object in this particular origin, go to this secondary bucket or secondary origin server and give me this content if it's present there as well. So here your content availability remains at higher side, and along with the caching, the response of the end user is seamless and has a request received at a very faster rate. So CloudFront also provides advanced features, which is like CloudFront functions. Basically, we it's a computation logic. It's a simple Node.js based computation, or a logic that you write onto the CloudFront to redirect or some requests or do some header manipulations, basically. And for some real complex use cases, you can actually use Lambda at Edge, which allows a deeper customization for requests and responses both. So additionally, we have a new feature called key value store, which is a low latency data access at the edge. So which can help us to make dynamic decisions very easy. So it's simple like JSON, where you have the key value, you store this key values into the key value store, you define it, and then you access this key value into CloudFront functions, and then you can just match on your criteria and make the decisions accordingly. So I'll just keep this little short so that I can speak more when I'm showing this into the actual demo. So let's move to AWS WAF. So what is WAF? AWS WAF is Web Application Firewall, which is helping to protect your applications from common web vulnerabilities such as SQL injection attacks, cross-site scripting, as well as malicious bot traffics. So how this WAF works? So basically, WAF has a rule engine where you can define some AWS managed rules. You can also define your custom rules. You can write your own rules as well based on your analysis, and you can start blocking your traffic accordingly. So when I say managed rules, they are very useful because they protect this protection. They give us the protection with very minimal effort, so that you just have to go to the WAF console, just select the AWS managed rules, which are majorly blocking SQL, cross-site scripting, bot traffic, and a lot more other, which I can show you in the demo. So you just go add the rule and save the rule. That's it. Your application would start blocking such malicious requests if they fall into that criteria. Let's go with the AWS WAF architecture. So WAF is basically integrating directly with services like CloudFront, application load balancers, API gateways. So whenever an incoming request is using a web ACL, which is essentially a collection of rules, these rules are getting evaluated in the defined order. So you have, whenever you configure WAF, you need to define the priority of rules, in which order the rules are going to get evaluated. So any of the rule matches, either the rule can be in block mode, count mode, or allow mode. Whatever the action of that rule is defined, and your request matches that particular rule, the action of that rule is being taken onto that request, whether the request is allowed or it gets blocked. And then you can log this request and analyze it for better visibility and fine tuning of WAF rules. Moving forward to what is Shield. So Shield is designed to protect applications from DDoS attacks. So in Shield, we have two flavors, which is one is Shield Standard, and then we have Shield Advanced. In Shield Standard is basically which is automatically enabled for all the customers whenever they enable WAF, and provides a baseline protection. Shield Advance offers capabilities such as enhanced detection, mitigation, and visibility. Shield Advance comes with a cost and a commitment of 12 months. And it then protects various types of attacks, including volumetric and protocol based attacks. When we all combine these services, we have a great secure architecture on the edge to protect our applications. So whenever a user hits CloudFront, where the content is being cached and delivered quickly, WAF quickly filters out the malicious traffic, and Shield provides protection on the network level. So this layered approach ensures that only legitimate traffic reaches to your origin. So here, in this case, your origin servers are also protected with respect to DDoS attacks. So let's quickly go to the live demo. So I'll quickly show you. So I'm already logged in to one of my account on AWS, and let's quickly walk you through. So these are all the distributions that you configure. So I'll walk you through how these distributions are configured and what each of the settings mean. So here, these are the general settings. This is the distribution name or the distribution domain name, where let's say you have your domain name called as application dot or app.example.com. So maybe in your DNS system, if you're using Route 53, what you need to do is you need to have app.example.com pointing to this cloudfront.net domain as a CNAME record or as an alias record. So whenever a user hits app.example.com, the request lands onto this cloudfront.net domain. It resolves to this, and this particular CloudFront distribution, as configured, serves the traffic or responses to your end users. So this is the domain. You have the billing models. Now CloudFront has also introduced the flat rate pricing, where you have a bundled package where you can see you have the WAF as well, you have the CloudFront as well. Both features come together on a bundle pricing. This is a pay-as-you-go model, basically, where it doesn't come with CloudFront, doesn't come with WAF and DDoS protections. This is the ARN of this when this is the last modified date, and let's come to the general settings. So here is the name that we can define what this actually means, a description that we need to define. Price class is where you can define what all edge locations you can use. So here you have an options to configure that, okay, I want to use all the edge locations. So I have the best performance, because since if your users are globally located, you have to always go with this location. Then if you have specific application which is only designed to some country, right, like let's say you are only serving your traffic to North America or to Europe, maybe you can only use North America and Europe, so your content is not cached, or your distribution does not use the rest of the edge locations situated maybe in India or Asia Pacific, right? So this is where your price class is defined. And then we have the HTTP supported versions, where we can define if I want to allow HTTP2 traffic, if I want to allow HTTP3 traffic as well. I have to just go and select this. You already have HTTP 1.0 and 1.1 are by default supported by CloudFront. We have this security policies where which defines what kind of ciphers CloudFront is going to use when you're going to have an HTTPS connections with the viewers or your end clients. Then we have alternate domain name. As I said, let's say you have an app.example.com. So I have just pointed it to wmsites.in, and I have created a SSL certificate in with star.wmsites.in in North Virginia region. One important thing is that CloudFront is always configured into North Virginia region, which is called as global region. And resources like ACM has to be always procured your SSL certificate in the North Virginia region, so that it reflects in this list here. If you have your SSL certificate in, let's say, other region except North Virginia, you won't see that certificate here. You need to reprocure that certificate in a US East 1 region. So in case if you have any default root object that you need to specify, you can just specify it here. So whenever if user hits app.wmsites.in, the user would actually make a request to index/index.html. So this is the default root object that user is always going to hit to. So these are some general settings where you can configure, you can add multiple alternate domain names here, and but you need to make sure that your certificate matches, your domain name is covered under the certificate that you have added here. You cannot add, let's say, app dot maybe example.com here, because your certificate is not going to cover example.com here. So you need to always make sure what domain names you're going to add there. So I'll save the changes here, and moving on to the security changes. We have a security tab where you can go and configure the WAF, so which is web application firewall. So I'll come to this point once I've configured the CDN. So very important part is now what are origins. So origins are the end servers where your content or your application, your data is being stored. So CloudFront is going to make a request to this origin, get the content, and serve it to the end users. So whenever you configure an origin, you need to just click on create origin. You need to define what all S3 buckets you can. So all the buckets that you have in this account would be listed here. Then you can also make sure you can connect to load balancers here, application ALB we call it as. So you can if you have any ALBs in this account, you can it would be listed here. You can also configure it to API gateways, media store containers, media package v2 endpoints, and VPC origins as well. So CloudFront now supports all these types of origin. Plus, if you have any custom domain, let's say that origin dot wm sites dot in, you can have this also as well configured. So, and this can point to anything, right? In your backend, it could be an on-prem server, it could be any external cloud, or it could be your simple EC2 instance but has a domain name. But whenever you enter this, right, you need to make sure what protocol it listens to. So whenever a CloudFront is going to make request to this origin, you need to make sure how is CloudFront going to make it, whether it's going to make on HTTP or HTTPS, or it's going to match viewer. So when this match viewer is basically, if I as a user is going to make request on HTTP, CloudFront is going to make the request on HTTP to the origin servers. So whenever you make an HTTPS request, you need to make sure that your origin supports SSL, and your because it's going to make a request on 443 port. If your origin server does not have an SSL and is only responding to port 80, you need to make sure that your origin protocol remains to HTTP only. If you have any specific path on the origin server where where you need to show that, okay, I whenever a request is landing onto origin, it should always fetch the content from this particular directory on the origin server, you can define this path here. This is a name that you want to give. You can add whatever you friendly name you want to add here, just to help you recognize what kind of origin this is. Origin mutual TLS, I'll not go deeper into this today. It's just about what kind of certificate it's going to have on the origin, and it's going to have a mutual TLS connections between your CloudFront and your origin servers. Let's say you want to send any custom specific header on your origin, which you are using it for some computations there, or some logging or some analysis at the backend. Then you can add a custom header, maybe called as XCDN, and you can just say CloudFront. Okay. So every request that CloudFront is going to make to the origin, it's going to make sure that this particular header is added to the to the origin that's being sent to the origin. So I'll just make it something like this. And then we have an added layer of caching, which is origin shield. So basically you can enable it, but this comes with, again, with an additional cost. And then you have an option to choose where your origin shield is going to be. So what is this basically? So if you remember, we have seen the architecture which has a edge location where your content is actually cached. And then when you when this content is not present in this edge location, you can actually make a request. CloudFront makes request to the origin shield if it is enabled, to see if origin shield has this content cached. If it has, it will serve the content from the origin shield. So what happens here is you have a two layer of caching now. So one is at the edge location and one is at the origin shield. So you can define that, okay, I want to have this origin shield configured in Mumbai region. And then you can configure is like what all connection attempts, timeout, response timeout. So CloudFront usually waits for 30 seconds to receive the response from your origin servers. Else you would see a 504 errors, timeout, gateway timeout errors, if your server is not responding to CloudFront within 30 seconds. This is where that you can have it configured from 1 second to 120 seconds. Default time is 30 seconds. So whenever you're seeing some errors, like you have a 504 errors, basically, you can go and check, what is the time that is configured on the response timeout. So what happens, even if your origin is serving the response, a 200 okay response to the CloudFront, but it's taking like more than 30 seconds, CloudFront is going to just cut the connection and it's just going to send the response from its own, like 504, origin didn't respond me in 30 seconds. So that's very important, how we are going to debug the 504 errors. And then we are going to create the origin. I hope it's getting created. Yeah. Then here I have configured an S3 origin. Let me show you already, which is configured. So I've chosen the S3 bucket from the list. Then I here have an origin access, which is very important concept in terms of securely accessing your S3 bucket. So whatever bucket, WM webinar is the bucket name where it is not public, it's a private bucket. But how is CloudFront going to access? Because it's actually going to make a request from edge location. So it's going to come from a public address. So here we have the access control settings where you need to define a policy that, okay, this is the CloudFront which is going to make access to S3 bucket, and you need to copy this policy and add it in your S3 bucket policy. So you're making a handshake between CloudFront and S3 bucket, saying that okay, CloudFront is authorized to make get calls on this particular S3 bucket. You can also make it restricted to specific folder inside your S3 bucket. It all depends upon what kind of bucket policy you're going to write, and on this OAC, which is called as origin access control. Public usually is not recommended because nobody keeps bucket public unless it is really required from a business point of view. And again, here you can configure origin shield for each of the origins that you're going to define. So origin shield is per origin that is configured and not on a distribution level. So moving forward, these are the origins. Let's see, I've configured this. And now the next very important step is the behaviors. So in behaviors, what you need to do is, so CloudFront, whenever gets created, it's always created with a default behavior, which means star path. So this is a path pattern, which is called as star. So any request is being made onto this CloudFront would always land onto this wildcard path, which is star. So here, let me show you what this configuration is. So you need to define the path pattern. You cannot delete the default behaviors. You need to select what origin is going to land to. So I'm going to select this. Are you going to compress any objects? So compression of object is like where you can have a gzip and broadly compression. So CloudFront, whenever it's being sending the response, it's compressing the response, saving the bandwidth here. Then we have the viewer protocol policy, which is HTTP and HTTPS. So basically this means that you are allowing users to make your application call on HTTP protocol and HTTPS both. So whenever a user is going to make request on HTTP app.wmsites.in, it's always going to stay on HTTPS. It's not going to do a redirect to HTTPS protocol. If you select this option, if you select the second option, redirect HTTP to HTTPS, it's actually going to redirect HTTP traffic to HTTPS. So you would see a redirection, a response in your network tab when you're trying to inspect the web application. What all methods you're going to allow: get, head, options, put, patch, post, delete, all those things. You can make sure that, okay, if any you have any traffic where you don't need patch, put, delete, you can just select get head options or get head, whatever is there. Then here is very important part of the caching and origin request. So let's take step by step, which is cache policy. So in this cache policy, we already have some managed cache policies, which is caching optimized, caching disabled. Then you have some custom query customs, which are you need to create. So what this actual query caching policy means. So this is going to define how long you're going to cache your content into the edge servers. So along with this, let's quickly see what this policy is. So here, whenever you cannot edit any of the managed caching policies. So it says you have the minimum TTL, that's the minimum duration of the time that is going to stay into the cache, the maximum and default TTL. Then comes the cache key. This is really very important concept of understanding how cache keys is going to behave. Here we are not going to cache any headers, no cookies, and no query strings. So let's say if anyone is making a request on app.wmsites.in, question mark q equals to 1, which is query parameter q equals to 1, it's going to get some response. Another user, if making a request as q equals to 2, the query parameter value is now changed to 2. But since we have defined no query strings to be cached, it's not going to create a secondary cache, but it's going to serve the same response that it served for q equals to 1. So you need to define in this what all caching attributes you need to have. So let me show you an example of simple custom policy, which is 1 hour cache policy. So here you can define, okay, what's the minimum TTL. I'm going to cache it for 1 hour. You need to always specify it into seconds. What all headers I need to configure. I want to cache it based on CloudFront is mobile viewer, host. These are all headers that you can add. Here you can also add your own custom header. You can select if your application is going to send any custom header. Then you can define what all query string parameters you need to make sure. So basically it creates a cache of a combination of all these parameters together. Any of the parameter is different, the value of any of the parameter is different, it's going to create a second cache there. So your cache is going to differentiate in this case. So if you add more and more into cache key parameters, probably your cache hit ratio might differ. So you need to understand when you're configuring it that how you can improve your cache hit ratio. So the more is the cache hit ratio, the more the origin load is kind of offloaded there. You can also cache on cookies. Usually we don't cache on any cookies or all cookies, because every request that is being sent from the browser takes all the cookies that are present in that browser for that particular application. So this would, if we select all, it would create variety of cache keys, and you would not achieve the expected cache hit ratio. And then you have the compression support. What is compression support? gzip and broadly compressions can be supported here. Now we have configured the cache policy, and when you don't want to cache it the content, you can just select the managed caching policy, which is caching disabled. So here the TTL is always 0 for all the 3 TTLs. Then we have the origin request policy. What this means is that what all headers you actually, or what all headers, what all query strings or cookies you need to forward to your origins. Usually we forward everything whatever is being sent in the request, but in some cases you don't want to overwhelm servers with all these headers, query strings or cookie parameters. You can just make sure that okay, you specify only certain headers and certain query strings that are going to the end user. So let me show you how to configure. Here you need to define what all headers you need to include. It's either all no headers, so CloudFront will not send any headers to your end user to your origin servers. If you configure all viewer headers, whatever a user is making request with headers, request headers will all be sent as is to the to the origin servers. You can also make sure that all headers we need to send, but except these 3 headers. So CloudFront will not forward these 3 headers. So this is the combination permutation combination where you need to define how these are going to know what your origin is going to receive. If you say that if you have some computation based on some query string parameters and your query string parameter is set to none, probably you would not see the response because you are not sending any of the query parameters to origins. Now, this is not related to the cache key. It's just related to what you're going to send to your origins and not your origin servers. Okay. Not in your cache key. Sorry. Okay. So this is how you configure your origin request policy. And now we have response header policies, which is like what headers you actually need to send to the users in the response. So I've configured one header. You have some managed headers like simple cores where you're going to see some cores headers, some cores with pre-flight requests. Then you have some security headers also. Based on your requirement, you can configure it. Let's say I will show you one head policy, which is ST header. Maybe it's configured by someone in the team. So what this actually means is you define the name, you define the description. Do you want to enable CORS, that is cross origin resource sharing? If you enable it, what all origins you're going to allow. So all origins, you can also customize the origins. Okay, I'm only going to allow from app.example.com or api.example.com, whatever you want to add here. Then select what all headers you're going to allow. These are all related to the CORS headers. I'd not go deeper into this in this session. Then if you have on a very simple terms, now a lot of applications are having security there, so you can also configure security headers to be sent to the browsers on terms of these are all the security headers: strict transport, we call it STS, X content type, X frame options, process scripting protections, referrer and content security policy, CSP. So all these things can be added here. So whenever you add this headers, the security headers would be a part of here. So let me show you an example here. I'll just make sure you can either origin override also. So whenever, if origin is sending some security headers, but you also have it configured on the CloudFront, it will override the origin values here. So let me add some headers quickly here. Same origin. Okay. And now this is what I've configured. And custom origins, custom headers is basically where you want to define that send these headers back to your users in the response. I'll just say it as CloudFront. So XCDN would always be sent in the response to the end users. Then we are going to have, in case if you want to remove any headers, like we want to remove vary header, you want to remove set cookie header, so you can just specify these headers here. Earlier, when this response header policy was not there, we had to write a Python or a Node.js code either on CloudFront Functions or Lambda at Edge, and we had to drop these headers or add these headers. Now, since we have this response header policy in place, we can just simply configure it on the policy itself, and the policy can be added or attached to a specific behaviors as well. So you don't want to added to one behavior or one path pattern, you can just don't you can skip that path pattern here. So let me show it to you here. We are still on the default path pattern, smooth streaming, then we have field level encryptions, and then we have function association. So as I said, we can do some edge computation. So here we have viewer request, viewer response, origin request, and origin response. So if I have to go back to the architecture, so here basically whenever this the second request, you see the number 2 is basically called as viewer request, edge to origin is called as origin request, origin to edge is called as origin response, edge to viewers is called as viewer response. So on viewer side, which is 2 and 3 or 3c, is basically called as viewer side, 3a and 3b is called as origin side. So CloudFront functions can be configured on the viewer side, either on the viewer request or viewer response, and Lambda attach can be configured on all 4 of this. But one limitation that we have is that if you on viewer request, you can either select any one of this function, either a Lambda attach or a CloudFront functions. CloudFront functions are only supporting Node.js today. Lambda attach has different kind of languages, but it do has some limitations as well. So you need to make sure that Lambda it needs a special permission in the IAM poly or IAM role that you're going to attach to this Lambda function, so it gets executed on the edge locations. So whenever you're configuring this, you need to create a Lambda function, you need to publish the Lambda function, and whatever the ARN of that published function is, you need to specify that Lambda function here. So once you have everything configured here, you can just save the changes and see the changes has been reflected. It will deploy. It will take another 2-3 minutes to get deployed. Meantime, I'll show you, if you have, let's say, what are path patterns. So basically you have your static content onto S3 bucket, you have dynamic content on your EC2 servers. So what you can do is you can have that, okay, whenever a request is landing to an extension called as star.js, that is like simple.js or index.js, whatever files you have, it all will fall in this path. And you can specify, okay, this particular path should go to S3 bucket. But let's say you have an API /star, anything that starts with API but ends with anything, you can say specify that, okay, if request or path is this origin or URI path, you should go to origin.wmsites.in. So this is how you're bifurcating where it's going to land, the request is going to land on your origin servers, and when it's going to send the response from. Similar way, you need to configure all these settings here. You have any functions, let's say you have for API, you don't have caching, but for static assets, you have caching. So you need to define the cache policies, origin request policies, response header policies accordingly. And then you can save that behavior. I'm not saving it here right now. So this is what the behaviors are, how your content is going to get served to the end users, what it's going to get applied to, what TTL, any computations, etc. Then we have error pages. So let's say this is error page configuration, which is like, so whenever we have an error for 403 from origin, I'm going to cache it for 10 seconds, and I'm going to send a custom error response. Instead of seeing access denied, a default error message from CloudFront, I want to route the users to a customized page. So I can say that, okay, I'm going to show a customized error response. So I'm going to specify the path. So this path should actually exist on the origin, which is the primary origin that's configured on the distribution. And you're going to send a 200 OK response to this request. So anything that's not there, or you have a forbidden object on S3 bucket, that object doesn't exist, it's going to take the request to 404. You would see a custom page maybe, and you would see a response as 200 OK. So you can configure the error responses as well, so that you don't show a generic error pages to the end users, but you show a customized error pages, so your user experience looks good there as well. Now it's part of invalidation. So what is invalidation? Basically, now your configured TTL onto your content, so your content is being cached onto the edge locations. So now whenever you want to remove the content, so let's say you have a JS file which is cached on your edge servers, but your backend team changed the JS files, okay, and your users would still see the older JS version because it's being cached into the end server, into the edge servers. So what you need to do is you need to create an invalidation so that CloudFront honors clears this invalidates the content, the JS file from the cache, and on it makes a new request to origin, so it caches the new content. So how that is done is that you need to define the path that, okay, slash star.js is something that I want to remove. All the JS files are to be removed. So I just specify the path. Each path needs to be specified this way, and you need to create the invalidation. So this is like a minute's time where it would clear the cache from all the edge locations, and you would start seeing the new content. So if you see the stale content probably, and you on your origin servers you have the new content, you need to go and invalidate this. So then we have the logging, where logs can be added across to S3 bucket. So here we are sending the logs of CloudFront logs, where we are seeing all the request details, what all requests it has, headers, query strings, cookies, everything can be logged, and we can do the analysis later for our own purposes. So this is where your logging has to be configured. So this is all about CDN configuration. Now let's go to security configurations. I hope people may have some questions, but I'll open up 5 minutes at the end of this session to quickly take up some questions. So now we have to go to the security configuration. So we need to enable a WAF configuration. So here we have to create a WAF. I'll open this WAF rule. We have WAF version 2. So another important thing that I missed telling you is CloudFront geographic restrictions. You can block the traffic from any of the country. If you have, let's say here I've blocked the request from Iran, so that anyone who is making a request from Iran may not be able to access my distribution. They would be not getting the content served to them. So you have either a allow list or a blacklist. So you can do either way, whatever is there, but you cannot do it both the things together in CloudFront. Let's go to WAF. So whenever you have to configure WAF, you need to have a WAF configuration, and you select what WAF policy it needs to be applied. So in WAF demo, we have some details about description with the ARN. Then it's going to have what's the scope. So WAF can configured either a regional WAF, which is in other regions, which can be associated with API gateways or with load balancers, which are called as regional resources. And this particular WAF is associated with CloudFront. So or it's being created with the scope of CloudFront. So this WAF is associated with CloudFront. This is the capacity units we call as WCU. It's web ACL capacity units, where it defines how many rules you have. So you can maximum ACLs we have is of 5,000 WCU. And sure, I think the screen stopped. So here you have the WCU units, and you have how many you have used out of. So 1500 is where you are being allowed. Out of that, 1275 is something that is being consumed. So I'm just about to reach 1500. After that, I would get some additional charge. Then these are some default configurations on captcha, challenge, and everything. Let me tell you on manage rules, where we have to actually define the rules. So here is that all the rules, where you say that, okay, this is the AWS managed rules, where you, as I said, you can just simply go click on add rule, click on AWS managed rules, and go to next, and you would see the list of rules that are being provided from Amazon itself or from AWS. And you can just say that, okay, admin protection is of capacity 100. So if I add this rule, it would consume 100 WCUs. So I just go here, I can scope it down to all requests, or either select a specific requests, that, okay, I want to only match this particular admin protection rule to, you can add multiple statements. Say that I want to only add this rule if the URI matches /admin, let's say. You can do some text transformations as required, and you can click on add rule. So this rule gets added. You can also change the priority of these rules, so you can move these rules up and down wherever, however you feel it is. And now you see this is being consumed here, and you click on save order. Now you see that, okay, this rule was of 100 WCUs, but we have got 102 WCUs. Why? Because I have enabled some additional inspection on this rule, which is I'm matching on the rule URI path as well. So any computation that you're adding onto this rule, or you're scoping down the rules, your WCUs are going to get consumed. So that's the reason it took 100 plus 2 WCUs. So this is the configuration. I'm not sure. I am screen share is getting stopped. So now you can see if I have to add a custom rule, I can just go and click on add custom rule and click on next, and then I can have IP based rules, geo block rules, rate based rules, custom rules. So I have to block a list of IP. So what I'll do is I'll create an IP set first, and I'll say that, okay, use an existing IP list. So I'll find out what all IPs I have here. I can say that, okay, this is what I allow, and this is what the action is. I am going to block this, I'm going to allow this, I'm going to send a challenge or a captcha. So when it is a challenge, so basically it checks whether this it's a simple JavaScript that get executed in the browser to check whether the request is a legitimate request or a false request. Then we have the captcha, where a user must actually complete a challenge where you have to solve a puzzle. So uh, if the WAF finds that this is coming from a malicious request, it redirects the user to the captcha page where you have to solve the puzzle and make qualify yourself as a legitimate user. So these are the actions that you need to take on this rules when you're defining. And then this is the IP set rule. We have another rule called as geoblock. If you're going to, this is where you're going to say that, okay, I'm going to block Afghanistan, Albania, Algeria, or I'm going to either only allow these countries. So that's how you're going to configure your WAF rule as well. Then you can also configure rate based rules. So these are rate limiting rules, making sure that, okay, you need to define that I have 2000 requests per 1 minute, per 2 minute, per 5 minute, or per 10 minutes. So I say that, okay, any user who is going to make a DDoS kind of an attack, where he should not be crossing 2000 requests in 1 minute on this entire application, basically. So this will help us to block that particular IP address if it crosses this rate limit. So usually a legitimate user may not make huge requests in a very lesser time window. It could be a bot who is just going to send requests to make sure that he is making a DDoS attack and bringing down the application. So these are some rate limiting rules that can be configured onto the on the configuration. So let me show you quickly a custom rule. I'll add a rate based rule to see that, okay, 100 I'll make sure 15 requests per 1 minute, and just save it. So rate limit. Okay, quickly show you here, and I've configured this. So I'll make sure that I want this rule to be executed first. So I'm making this onto the top of this rule, and I'm going to save the rule order as well. This is very important. You need to save this rule, else it won't save and it would remain at the last priority itself. So going back, this is where you're configuring the rules. You can also configure custom body responses. Let's say you're getting blocked and you want to show a custom response. Then you can add a custom response saying that, okay, I want to have you are blocked, something like that. So I'm going to save this. So whenever WAF is going to block, I'm going to see this simple response called as you are blocked. Instead of saying a request block, the standard generic AWS response on the screen. Here is the dashboard where you can see all the traffic, what kind of it's blocking, all the bots that are being allowed, DDoS, IP reputations, anonymous IPs. There are a lot more rules. Probably we can have another session maybe in future where I'm going to explain each and everything details about this as well. So right now, since this is a demo, we don't have any data here. Then there's something new called as AI traffic analysis. So AWS AI is actually analyzing the traffic and helping us to understand what are top crawlers, what are top paths that are being requested, any bot traffic by volume. It's being categorized here. Most access paths it's going to show us here. So this is how you're going to get your analysis as well. And then you can actually configure the logging as well, whether you want to configure it to an S3 bucket or Kinesis firehose, what protections you need to enable. Where when I say protection, this is where what you're going to log actually. If you want to redact certain fields, say from the response, when you're into a payment industry, you want to block some, you don't want to log some traffic, or you have to redact something, you can just say that okay, this particular redact should be either hashed or it should replaced by some static strings. So you can add that configuration as well when it comes to PII data. So this is where you want to add this configurations. So at the end, this is how you configure the WAF, and you have option to manage this resources. So this particular WAF, where it is being added, you can specify it here. You can add global resources, other CloudFront distributions. So you can select what all CloudFront distributions it has, and you can choose the distribution and get it applied here. So either you can deassociate, or you can associate the distribution, the WAF, to the CloudFront distribution. So this is how we have configured the WAF. Now let's see if we can hit this domain called app. Sure, let me see if this is actually pointed to anything. Okay, I think the pointing is not done, but let's open the cloudfront.net domain. Yes. So now this is the pointing was not done there. So I think app.wmsites.in is not pointed to this distribution in the DNS, hence is not able to resolve. But when I hit it from cloudfront.net domain, I'm able to see the page that's coming up, right? So this is how you're being loaded from this. Now if you see here, we had configured some headers in the response, which are your security headers, and some custom header also we added, that is xcdn. So you see, I'll show you a quick sample here. I am now going to make the request on http. Okay, so what happens here is, you see 307, which is an internal redirect, and it's going to send the request to HTTPS. So I could now see the request on HTTPS. Filter it out. So now you see this is a hit from CloudFront. Okay, these are the response headers that you can see. Let me zoom. Oh, it's not zooming in. Yeah, so you could see the age, you can see what's the end server. You can have this servers kind of mitigated, you can restrict these as well. Then you can, I mean, you can drop these headers when you're sending it to the users. Then you have this XAMZ CFID, which is the request ID, what pop it actually served from, what kind of encryption it had, what is it a hit from CloudFront or a miss from CloudFront. And then you have the same origins and no sniff. Now you don't see the security headers because this content is cached. Let's go and invalidate the cache, so that you see the response headers as well. So when you are going to invalidate everything, it's going to be /star. So the invalidation is in progress. So once this invalidation is completed, we should be seeing a miss from CloudFront on the first hit, and on the second hit, it should be a hit from CloudFront. So it's in progress. Meantime, let's quickly check. We have the ST header as the policy. Okay, perfect. And yes, the invalidation is complete. I'm going to filter this out. I'm going to make a hard refresh. And now I see I've got some ST header we called a server timing header. Let me show you the policy as well, which is added. That is ST header. So I have uh, enabled the server timing header is true. So you see the server timing header is coming up. I have enabled security headers. You see STS headers. You see X content type and X frame options as well. Plus, you see a header called as XCDN CloudFront. So this is the header which I have defined that needs to be sent as a custom header to all the responses that CloudFront is going to serve. And I think the screen share stopped again. Sorry for that. So here you are seeing these headers, and along with this, the vary header and set cookie header is being dropped, so you don't see those headers in this. If origin was sending them, it will be dropping these headers to the CloudFront before sending the response. So this is how it's working. Your headers, your cache policies. So okay, this was a miss from CloudFront. I do a refresh, and now it should be a hit from CloudFront, and you should still see those headers coming up: XCDN and strict transport and your server timing headers. Okay, server timing is not there because it's a cached content. So now quickly showing you to the blocking rule. 15 is what I'm just making the request quickly. If see the requests are getting there, it should ideally block me, because if I'm making more than 15 requests, hope this policy is attached. Okay. Yeah, now you see it's blocking the requests. It's showing me 403. Sure, I think the screen share stopped again. So this is how you would be getting blocked if you're trying to make cross the rate limit rules. Till the time again my rate goes down, it won't allow me to make that requests. Oh, sorry, I didn't enable the custom response here. We just added, and the custom response is 403, and uh, make sure it's blocked, and I save the rule. So it would now show me you are blocked. So now should. So this is how you enable WAF. You enable your rules as per this, as per your requirements. You can fine tune these rules whenever you analyze the logs. Logs can be analyzed using Athena, using making the SQL queries onto it. And see, you now see a request called as 403 because I made 15 requests, and it says you are blocked. So this is a custom response that I have configured to show the user. Earlier, you were seeing a very generic response called as access denied and XML schema here, which is a default response from AWS, because my origin is S3, so it showed me a response called access denied. But since I've configured a custom response, it now showed me you are blocked. So uh, at the end of this lecture, basically, what I want to give you a heads up is that this is how you are going to configure your WAF, your CloudFront, and moving to common use cases, these are one of the most widely used scenarios where you have it can be used when you're using a website hosting. Your API acceleration needs to be done. Some APIs are cached, some are dynamic. When you have to protect your application against DDoS protection, all your websites, you want to do a bot mitigation. So for all these purposes, all these use cases, you can have CloudFront and WAF in place along with Shield and Shield Advanced as per your requirements. So what is really important when you are actually defining or designing this edge architecture is the best practices you need to follow is basically uh, you know uh, caching content strategy, so that you are able to serve the right content. You're not caching the wrong content, so your users don't see incorrect content when they're making requests. You should always start with managed WAF rules, so that you don't miss anything, or you're being protected right from day one. Instead of writing custom rules easily, you can just quickly select any managed rule and move forward. You should be monitoring the WAF logs continuously, because this is actually going to help you to fine tune your rules, because these are the generic signatures. But there could be cases where probably it is a legitimate request, but it's still getting blocked. It's called as false positive. So in this case, you can fine tune and you can apply some scope down statements, so you're not blocking the legitimate traffic. And one of the best practices that you need to follow is always deploy this WAF or any configurations to staging environments. CloudFront has the staging environment functionality now. You can configure a staging distribution, you can deploy it there, test it out, and then move that configuration to production. So these are, so considering the key takeaways, or to summarize, edge architecture designing is very essential today whenever you are because all these applications, when it comes to e-commerce, fintech, right, OTT platforms, they are real modern applications, and you have to actually improve the performance and security, because these are the most targeted applications for attacks. And where it comes to CloudFront and WAF together, they can help to increase the performance as well as security on your web applications. So with this, I am open for any question and answers. If any, feel free to drop the messages in the chat section. So if the content is dynamic, what are the advantages of using CloudFront? So let me tell you, it's the question from Execute Pi. So basically, you have an API, right? When this called as dynamic. So what it would help is you have your APIs are, let's say, hosted on API gateway or EC2 instance. The first benefit that you would see it is in the cost, because the data transfer out cost from an EC2 instance is at a higher side when if it's compared with the CloudFront. Plus you would see some acceleration there as well, since the traffic is being routed there. Plus you can do some computations at the edge as well. If it is required, you can drop some headers, you can add some headers. So it depends on what is the use case and what you actually want to achieve. So but when I see it advantages of CloudFront for dynamic acceleration, this is where you can get these benefits of cost savings, and plus a dynamic acceleration can be happen. You can try to cache some content if required. Does adding Lambda at edge or WAF significantly impact response times? I would say it won't significantly increase the response time, because these are the edge functions. As I said, these gets executed within milliseconds, and as I said, we have limitations and restrictions on the edge functions. So you don't add very complex logic onto it. So it's just the header manipulations or some response tweaking that you need to do. So it won't add that much of response impact times. When to use Lambda when to use edge Lambda versus CloudFront functions with CloudFront. So okay, so simple terms, right? I'll give a very simple example. Let's say you have a list of redirections, right? Let's say you building an OTT platform, and all your URLs are now old URLs now, but you cannot change that URLs into the application. What you just need to do a redirection. So if any old content is being the URL, the old content URL needs to be redirected to a new content, new URL, new where the new content location. you can just specify these list of 1,000 URLs into the key value store. It's a very key value store. So you have the old content and the new content as the value, and you can just use CloudFront functions, check the URI, and just respond it from there. But when you want to when you will go with CloudFront Lambda Edge, where you want to do some real computations, right, where you want to check multiple conditions, or you want to change the origin on this content level itself, that okay, this is the path, or this is the content, but this content does not exist in S3 bucket 1, but it exists in S3 bucket 2. You can dynamically change the origins based on the path patterns, based on the headers. So basically, that's where you would need to understand how you're going to use CloudFront functions and Lambda at edge. The last question we have is that when a new code releases is pushed, how the new code will be reflected in the same path was cached earlier. So yes, so this, I'll tell you how this, whenever, that's what I said, when it comes to JS files, right, when a new code is pushed, maybe some files might have changed. So you either need to purge the cache or invalidate the cache for that specific content or URI path, so your new content starts getting cached again. Now, when it comes to a CI/CD process or DevOps process, usually people include this invalidation in their deployment process itself. So they just make a call to CloudFront API call, create invalidation, specify the paths, and once they in the DevOps pipeline itself, the content is being purged. So whenever the deployment is successful, the automatically older content is purged, and you could see the new content. Are there any disadvantages to using CloudFront? To be honest, I don't see any, because most of the major companies today in India are using CloudFront. It is actually helping to solve a lot of challenges that earlier we used to have. You are offloading the computation from origin servers to your edge location, so your computation is becoming closer to end users. You are able to offload your origin server, so your origin doesn't have to be 3x, right? You can just keep your origin to 1x and just serve the traffic to millions of users. So because your content is getting cached, so probably I don't see any disadvantage so far here in this. We have a question from here, which is, when there are high traffic applications, what are the best practices which is also cost efficient when there are high traffic applications? So as I gave an example of OTT platform right now, where you would see a lot of users seeing the content, right? So best practices is again where I say that your caching strategy. So you should make sure that you know how long your content should be cached. You know that okay, my video is not going to change, right, for let's say 1 month. So you need to specify the cache TTL for 1 month. If you specify the cache TTL for 1 day, probably it's going to make your lower down your cache hit ratio and increase the requests landing onto your origin server. So this is one part where you can actually see a cost efficient, because your data transfer is not happening through origin but is happening through CloudFront. So that's where the you would see the cost if benefit there whenever you have a high traffic applications. We have one question from Ajinkya. Is origin shield applied to single distributions, or can it be used across all distributions within an AWS account? So origin shield is basically on a single origin that is defined. So as I said, you cannot because it's going to cache the contents for that specific origin itself. So not sure if maybe today it maybe something is released, but as far as you cannot share this origin shields across the AWS accounts. Okay, so I think this helps a lot, and it was really great talking to you guys, answering your questions, and hope everyone felt good seeing the live demo as well.
Thank you so much, Abhishek. This was really a great session. I would say you literally covered end to end. Uh, CloudFront WAF, the configurations were really detailed. I'm sure this is somebody who goes through end to end can literally host something on the production. Of course, you did not cover DevOps, the CI/CD aspect, but uh, the session was very enlightening. Thank you so much for that, and I'm sure the questions were also quite relevant. Uh, So yes, thank you, audience. Do keep all these questions coming. This is pretty important. Abhishek, thank you so much once again for being there. All right, we'll jump to our new to the second session of the day, which is from Sankalp. He is going to talk about EKS, MCP, the new buzzword in the AI industry. Sankalp, hi Sankalp,
Hi Naresh.
how are you?
Yeah, I am good. How about you?
I'm doing great, man. I hope you're excited about this session of yours,
Yes,
EKS and MCP.
excited to be part of this meetup and the
Thank you
community.
so much, Sankalp. The stage is all yours. Please take it.
Okay. So hi everyone. We'll be talking about simplifying Kubernetes operation with Amazon EKS MCP servers. So it was a great session by Abhishek previously. Now we'll be moving towards EKS MCP server. So, how many of you use MCP servers? How many of you use MCP servers in your day-to-day tasks? Can you comment? Let's see who all use MCP servers. And my next question would be, who all have built their own MCP servers? Okay. Okay, before we start, just a quick introduction from my side. I am Sankalp Sandeep Paranjpe. I work as a cloud security engineer. I am also part of AWS Community Builder program. I also lead volunteer activities at AWS User Group Pune, and I was also a former AWS Cloud Club captain. So yeah, let's get started. What we'll be covering in this session is the current workflow, how Kubernetes operation look like today, then what is MCP, the protocol, how it works, what is its architecture, EKS MCP server, then a debugging session, and basically the security and few limitations, and we'll wrap up the session. So moving on, how do we debug a pod today? So generally we use basic six commands before even we have a hypothesis. With a kube, we use kubectl to write a command on CLI, and it authenticates to Kubernetes API, and then basically we get the information. So kubectl config use context for specifying the context, then get pod, describe pod, logs from AWS, CloudWatch, and events. So these are the basic things that in general we do while debugging a pod. And each tool covers one thing. So let's say kubectl gives you the information, but it has no memory between the sessions, or basically yeah. So AWS console is there. It is good for a snapshot. Then CloudWatch is there. It has logs, but again, it has no link to the objects, Kubernetes objects. You have runbooks. You have Helm that basically handles the deployment configuration, but there is no runtime state and dashboards. But again, how do you correlate these all things? So let's take an example of a real incident. How does it happen? Let's say there is a payment service pod running, pod in a crash loopback of in a production. So the payment service, it's a pod in the this state. Now what happens at basically, just a second. Okay, so let's say you get a pager duty call and that payment service is down. Then you run these commands. You do kubectl get pod, describe pod. You check the logs. Then you find out that TB host environment variable was not set, and it was removed last night. CloudWatch log says that, and you just set that variable, and you basically the pods becomes healthy. Now in this you see the timeline of resolving that particular issue. We'll be talking about this. We'll come again on this specific point. So now coming to what is MCP exactly. So MCP is an open standard for basically connecting AI applications to external systems. Those external systems can be anything like databases or any APIs or any of your local files, or let's say in general terms your location map, etc. So it's a one standard. So for all different AI services clients, it's a one standard. So you don't need to create a custom integration for every tool. Now it also has live data. So basically AI reads a current state from your real system, basically the real file which you are basically integrating. And obviously AWS IAM is there, so what access is being provided. So according to that, it will be accessing the data. Then basically the MCP server exposes tools with typed input, and outputs also vary by the server version. And all the authentication logging, those are basically managed by AWS in case of AWS managed MCP servers. So all the calls are signed with signature version 4, and all the calls which you make, those are logged via CloudTrail. So authentication and logging is also take care part of in case of basically the managed MCP protocol from AWS. Now, this is how, in general, the structure looks like. So you have AI applications. Those AI applications can be your web clients, desktop assistants, like a Kiro agentic ID from AWS. Then you have any specialized agents or workflows which you have created, any CLI tools. So you can use MCP protocol to connect your data sources. Those can be the file storage or any monitoring tools, any project workflow tools, or any collaboration tools, location, or any files, etc. So this is the basic structure of basically how MCP connects the AI application to the data sources. Then MCP versus building your own integration. So let's say if you are building your own integration, then you need to write custom code for each service. But with MCP, you can use same protocol across various services, various workflows. And again, with MCP, without MCP, you need to write the authentication. You need to handle authentication for each tool. And with MCP, MCP client does the signature, basically signature version for signing. Then without MCP, you will have the training data only on which the model has been trained. But with MCP, you will have the live data because the tool is fetching the data, tool is calling the data. Then tool discovery may be hard coded in your agent code in case you are not using MCP. But in case of MCP, what happens is server is going to tell that which tool is to be used. Let's say in case of this Kubernetes, so list cluster is one of the tools which can be used to list the clusters. Then get CloudWatch logs. So server is telling which specific tool is to be used basically in what case. Then input checks, prompt engineering is there, but in with MCP, what happens is JSON schema is there on each tool call. Okay, so these are few differences and what benefits are there while using MCP. Now coming to the components of MCP, so this is from the official documentation of MCP, where you have a MCP host. First component is MCP host, where you have multiple clients initiated. So MCP host can be any of your applications, AI applications which you have built, and you will have multiple MCP clients. So let's say your MCP client one is going to connect to a local MCP server. So while connecting, it is going to use standard input output basically for communicating in the client server model. But when it is connecting to a remote server, it is going to use streamable HTTPS for the connection and the response in this client server architecture. Now, coming to AI clients that support MCP. So there are multiple AI clients or IDs, which you can say. Amazon Q Developer is one of the AWS native client. So we can configure it via ID plugin or via CLI or via EKS console MCP settings, and we can use that. So in our demo, in one of our demos, we are going to use Amazon Q Developer with the MCP server. Then another option is using Amazon Kiro. So it is an agentic AI ID from AWS. So you can add MCP to basically Kiro or a cursor, and you have Claude or cursor. Those are the other IDs. Now, before MCP and after MCP. So let's check the difference. What happens? So before MCP, AI only knows its training data. So whatever data has been trained, so only that data is there with the model. But when you use MCP, it is basically calling the tools. So and it gets the real data. And with before MCP, there is no cluster state basically, and with MCP you get cluster state with each tool call. And if you don't have MCP, again custom code integrations and more complex work would you have to do. With MCP, it's a single protocol you can use across various services. Now, two things that MCP gives to the AI, that is context and tools. So in case of our Kubernetes, EKS, basically live data AI can read. Basically, then we can read the live data. So pod status, restart count, or recent events, or any node resource usage, deployment rollout history. So we can get the live data. And with the tools, only we are going to get this data. So we can list or describe the cluster, get pod logs, or apply manifest files, or we can write our own manifest files, and we can scale the deployments. So these all things can be done using the tools. So how MCP fits into Kubernetes basically? So AI assistant you have, you can use Amazon Q, Kiro, Claude, etc. You will be writing a prompt. Basically, you will have MCP client inside AI assistant. Then the tool will be called, and there will be MCP server. So it can be, yeah, AWS EKS MCP server can be basically local server as well as AWS hosted server. So Kubernetes, it will again call to the Kubernetes APIs, and you'll get the required data from the tool. Now, authentication, for the authentication, MCP client signs with the signature version 4. And before going to more deep dive into the EKS architecture, let's see few more MCP servers. So how does AWS has provided us with the open source MCP servers? Just a second, I'll just share my screen. Okay, so this is the open source MCP servers from AWS, where you can find all the documentation about the different MCP servers in all the categories basically. So you can find MCP servers in different categories: documentation, infrastructure deployment, AI, machine learning, and these different categories. Also, it provides you with the documentation how you can use that particular MCP server. So let's say in our case, we'll be talking about EKS MCP server. So how we can install that particular MCP server, how we can configure that, and how we can use that. What are arguments you can pass in different options, how the authentication would take place, and those things. So this is one of the useful resources provided by AWS for all these MCP servers. So let's now basically move further. So how EKS MCP architecture works? So you have AI clients, Amazon Q, Cloud, or Amazon Kiro ID, and MCP client layer is there. So MCP protocol, it does the tool discovery, which basically tool is to be used, and all the requests are signed by the signature version for signing and responses parsed. So EKS MCP server is there, so it will also do IAM validation. So what permissions have been provided? All the calls which have been made will be logged via CloudTrail. So we'll be seeing how those logs are done via CloudTrail, and AWS APIs, EKS APIs return the information to the clients. So what exactly EKS MCP server does is basically we write a prompt in a natural language, then it calls a tool. After that, basically it calls a Kubernetes API in the back, and it structures a result and it gives us back. So let's say we are saying, show me pods not in running state. So what it is going to do? So tool is going to call, it was going to list pod with status filter, and at the backend a Kubernetes API is going to function in actual. So it is not basically replacing your Kubernetes APIs. Those are there intact. It's just a way to interact with those APIs. Okay, so the how does the full data happens is that you have a cluster data. So pod status, event, container logs, node metrics, and those things. So how it happens? Tool is going to fetch that data. It will make that it structured, and it will share it with us for our review. So uh, in this way, the data will flow basically. And let's talk about one of the scenarios, crash loop back off in production. So we were talking about payment service at a very beginning of the session. So we'll see how we are going to debug that. uh, so without MCP server, there are so many complexities. It will take very much time to find the root cause. With MCP server, you'll have one conversation and one session of that debugging, and basically you'll have faster access to the logs, events, and again faster root cause analysis. So let me share my screen and let's go to our VS Code to check the setup. Any questions till now? Okay. Uh, Let me just go to the VS Code. Is my screen visible? Okay. So now it would be visible, right? Okay. So I have set up uh, a simple demo app where we have a payment service, a simple app.js. I have created a basic Docker file, and basically we will be going to Dockerize it and deploy it. Apart from that, we have the manifest, we have the Kubernetes manifest files for creating the deployment. So first for namespace, then we are going to create a deployment, its services, and RBAC basically. So what we are going to do is I have created some shell scripts which I have already set up this Kubernetes environment. So let's go towards the AWS EKS console. So here is my cluster where basically the uh, application is running. The application, I had Dockerized that image. I Dockerize that code, and application is running on my EKS console, EKS nodes. Now, what I did to set up a cluster, basically, I have created a shell script where I used EKS CTL to create a simple cluster, and I have updated the kube config. And basically, the simple EKS cluster setup using EKS CTL. Then I have configured IAM roles, required IAM roles for the access control uh, in the cluster. And after that, few things I had to verify, and uh, now I have built that image for the payment service and pushed that specific image into my ECR repository. So going to the ECR repository, we would be able to see uh, the image pushed on the ECR repository. So payment service image has been pushed here. We are able to. Okay, a simple image, very small image has been pushed to, and we are using this image in our case to deploy our application basically. This is the basic setup of my service of this demo. Now, what I did is that I'm using Amazon Q developer, where I'll be asking a few questions in the natural language, and MCP is going to help me to debug why this issue had occurred. So first, basically I am asking list the pods from my cluster named EKS MCP demo from US these two regions specifically. So it is going to call a tool list KTS resources from MCP server, EKS MCP server, which I have already installed. To install that specific MCP server, you can add it to the mcp.json file in your VS Code, simple config file, where I am passing arguments for running this MCP server. I am also allowing to write and allowing sensitive data access as well. This is the basic file, and it is using this specific tool list KTS resources uh, to find out what all pods are there. So it is going to bring me the pods, what all pods are running. So in the kube system namespace, 8 pods are there, and the payment namespace, 2 pods are there. Total 10 pods are there in this. Okay, and when I also gave up a simple natural language prompt that I have payment service deployment in the payment namespace, that's failing because I have intentionally written a wrong deployment file to simulate this scenario. So now it is going to basically check why the pods are failing, what is the issue, and it will come back to us with the latest status. So it is going to check the logs, the status in the Kubernetes. Now it is checking, it is using the tool called Manage KTS Resources tool. And again, next tool it is using is get KTS events. So all the events from Kubernetes it is going to take and perform the analysis. So now it says I have found the issues with your payment service pods. Both are in crashed loopback state with 37 restarts. So what is the problem? So wrong container image, then health check failures. So readiness probe was failing, liveliness probe was failing. The environment variables. So this environment variables was set which suggests intentional failure mode. Now what's happening? Container starts Nginx on port 80, and health probes try to reach it on 3000, and connection is refused obviously. Then after 3 failed liveliness probe, container is killed. So now we have to fix this. So it is asking that would you like me to fix and update the deployment. So using this tool, we will be able to update our deployment file as well. So using manage kate resource uh, uh, tool from the EKS MCP server, we are able to write the correct deployment file. So uh, correct file with correct image and correct liveliness probe, readiness probe, and yeah, it is going to fix it. And again, we would be able to access that application. So deployment would be triggered a rolling update. In this case, it was a basic scenario where new pods will come after like a few seconds. So this this is how we can utilize EKS MCP server to debug a basic error in our uh, environment. Yeah. Yeah. So this was the one scenario which we debugged using Amazon Q Developer. And this is whole theory, like what we did. It was whole theoretically mentioned here. Basically using this. Now for IAM, how authentication works is with basically MCP client signs the request with AWS Signature 4 version, and this IAM role basically is used in the execution environment. So the client or the model is never touching your credentials. Those are there with the role. And again, MCP server is validating each request before routing. So let's say in terms of read-only IAM policy, it has access to only describe cluster, list cluster, filter logs, these things. But when I give a write access as well, then only it is going to apply those files. Let's say we created a deployment file and applied it. So again, based on the access, it is going to do that. And how CloudTrail is and used and what gets logged. So all the events, all the calls which you are making using any of these tools is getting logged there. So how it is there? Event source. It's a general structure of CloudTrail event, and you can use this for any compliance evidences or anomaly detection or any of the reviews at a later stage. So yeah, before coming, okay, so there's a question: do we really give write delete permission set in production while using MCP server? Okay, so currently this MCP server is in preview. It is not general available. So it is still in preview. So it is like advised to do some experiments, and after some experiments only you can, like, it is still not general available. So definitely you shouldn't give delete or write permission in productions, I would say. Once it is general available, maybe we can. So yeah, 6 things we need to remember, that this is just another way to talk to the cluster. So it is not replacing any of the APIs, the EKS APIs or Kubernetes APIs. Then AI sees the data, it queries and nothing more. Basically, whatever data is available, the live cluster data per tool call. So whatever data is available in the cluster, tool is going to call and you will get the data. And IAM is always there. So whatever permissions have been configured via IAM, that data is only you will be able to see according to the permissions defined for your user or your IAM role. And AI is going to basically suggest you the things, but you need to decide what you need to take action, what you have to do. And yeah, you can start with read only things. You can try, you can experiment with these tools. And yeah, as previously mentioned, it's in preview. So you can check the docs for latest updates on that. So yeah, we are coming towards the end of the session. If there are any questions, we can take up, and you can connect with me on LinkedIn if you have any technical doubts. We can also discuss. So if there are any questions, we can take up. Okay, so security is a big concern with MCP, because you know what type of data and what is the access control for that data. So that is being accessed by MCP server. So that is one thing. Another thing is the vulnerabilities when you are using web applications with, excuse me. So when you are using web applications to show the output of this MCP data, there are web vulnerabilities including cross-site scripting and other vulnerabilities. So that is also one of the concerns. Uh, One major concern is about the access control of the data and what type of data you are basically accessing. So that is thing. Okay. Any more questions? Okay.
Thank you, Sankalp, for the wonderful session and introducing all of us with the cutting edge technology and the MCP servers. And honestly speaking, I have recently started using MCP servers and just sorted my life. Probably I'll be able to use in my project. Um, can we have Abhishek on stage as well? Yeah. Okay. So we all four are here, and there is one small question from me to our speakers if they want to share something or give any suggestions to the new learners.
One suggestion is basically always from my side is to new learners is don't go fast, go with the basics, understand the basics so that you are not facing challenges. At the end of the day, the issue is always with the core logic or the core component of the thing, and we just try to debug at an advanced level, right? So and one of the very important suggestion is documentations. So it takes time to read the documentation, but it's always better to have a glance of the documentation so you're not missing the smallest part of the configurations whenever you're doing anything on production or stage or dev environments.
From
That's
my side,
really, yes,
yeah,
Uncle,
good.
please go.
From my side, I would say is to the learners is that you should build the things, you should do the hands-on. That is going to help you to learn the technology. And doing the things end to end is a very good way to learn a specific technology or a service. So I would suggest that.
That's really great, and especially in the world of AI, when everything is going with the vibe coding, people tend to forget to review as well sometimes, and at last we get to know that where is the problem. Then we start debugging the things.
Yes.
So yes, this is really a nice suggestions to the new learners. And we are at the end of our session, and I would like to thank each and everyone, Abhishek and Sankalp, for joining us, for sharing your insights onto the very nice topics, I would say. And thank you for taking out time over the weekend. And I would like to say that this meetup isn't just about the sessions or the presentations. It's about building a strong community where we all, learn from each other and share real world experiences and grow together in the AWS journey. And thank you everyone for attending the session. Your time, participation, and valuable contribution made it truly engaging and meaningful. We hope to see you the discussions insightful and beneficial. Looking forward to connecting with you again in the future sessions. And the announcement which I would like to give is we have planned our meetups, regular meetups, every second weekend of the month. So our next meetup will be on the 9th of May, which would be again a offline meetup, since this is the first ever virtual meetup for us. And it went, I believe, right, Naresh? Do you want to give any thoughts on it?
So far, this has been wonderful. Our next meetup is going to be offline, but yes, depending on the feedback that we get, we might look for hybrid mode. But so far, this is going to be offline. So yeah, do share your feedback with us. How did the sessions go? Yeah, that will be a great help. Thank you.
Yeah, thank you. Thank you, everyone. Thank you so much for joining us. Bye
Bye
bye.
bye.
Bye.